Alright, this is part 2 of our lesson on right triangle trigonometry. This is a test, so this would be good for you to use to review if you're practicing for your own test on right triangle trigonometry. If you haven't, this is part 2, so if you didn't watch part 1, go back and do that first. Alright, in number 7 we are supposed to decide if triangle PYT is a right triangle. Well, if it's a right triangle, the Pythagorean theorem should work. Alright, in other words, if this is a right triangle, then 8 and 6 are the legs and 14 is the hypotenuse. So let's check and see if the Pythagorean theorem holds true for this triangle. In other words, does 8 squared plus 6 squared really equal, or I'm putting like a little question mark on it, does it equal 14 squared? That's what we're trying to find out. 8 squared plus 6 squared is 100. Um, 14 squared is 196. So 100 does not equal 96. So that means that this is not a right triangle. So we could say, since the Pythagorean theorem doesn't hold, I'm going to type this. Since the Pythagorean theorem does not hold true, triangle PYT is not a right triangle. Alright, number 8. ABCD is a square whose side is 8 units. Find the length of diagonal AC to the nearest tenth. Okay, diagonal AC is this right here. Okay, that's diagonal AC. And they already told us that this is a square, so these two sides are the same. Alright, that tells me that this is a 45-degree triangle. Alright, because it's a half a square. It was 90 degrees, so split that down the middle, you got 45 degrees. So the pattern, once again, for this particular special triangle is leg, leg, leg radical 2. So in this case, that gives us 8, 8, 8 radical 2. Okay, so the length is, in fact, 8 radical 2. Now they want the nearest tenth, so that means a decimal. So we will go to the TI-30XS multi-view, and we will type in 8 radical 2. Okay, radical 2. At first it just gives us 8 radical 2 again, but then we hit this toggle button to force the decimal out of it. So that's 11.3. Okay, 11.3. Were there any actual units? No, just units. So that's it for number 8, 11.3. Okay, number 9, better zoom out. You are standing 1,200 feet away from the base of the Great Gasp ride at Six Flags, looking at the top. You are standing at the angle of elevation that is 11 degrees. How tall is the Great Gasp ride? Round to the nearest foot. Alright, now here's a picture of the situation. Now I know what you're thinking. That does not look like much of a ride. But it is, because what's going on is that this is a very tall ride, and people are in here, and it's hollow, okay, and it's dark tunnel, and so the ride attendant gives you a little shove and pushes you into the opening of this hole, and you fall straight down this tunnel to the bottom, and then there's a little trampoline down here at the bottom, like in Divergent, when they jump in the building and they think they might die, but there's actually a net down here. So it's the Divergent ride. They could have called it Divergent, but they called it the Great Gasp. So it's really quite a ride. In fact, you want to ride this ride now, even though it's fiction. Alright, anyway. You're 1,200 feet away from the base, from the bottom. So that's 1,200 feet is right here. They said there's an angle of elevation of 11 degrees. Angle of elevation is how many degrees you look up. So angle of elevation is always measured at the ground here. All right, by the way, if they ever say something about angle of depression, that would be like right here. You know, if you had an observer up here, like a giant, this would be a very giant anyway, I'm getting off topic. Got to take my meds. So 11 degrees. Now we're supposed to figure out how tall the ride is. Okay, with this information. So the height of the ride is going to be this x right here. So let's see, which trig function are we going to be dealing with? From the perspective of 11 degrees, this x is opposite, and this distance on the ground is adjacent. So, opposite, adjacent, you say? Why, that sounds like the tangent function. So let's do that. So we're going to say the tangent of 11 degrees should equal opposite over adjacent. Alright, so that's x over 1,200. So we just have to solve for x, and that is easily done by simply multiplying both sides by 1,200. Okay, that way the 1,200s will cancel, and if you just do 1,200 times tangent 11, that'll be your answer. Okay, that didn't work out the way I planned. So let's see. I said we're going to do 1,200 times the tangent of 11. Alright, so that is 233. And you know what? I think I vaguely remember them saying something about rounding to the nearest foot. Alright, so that means like a whole number. So I won't round up, so it'll be 233 feet. Yeah, 233 feet. Alright, that's the answer, number 9. Okay, let's move on to number 10. Given the triangle below, what are the measures of these things? AC, A, and B. Alright, well, this is a third opportunity to use the Pythagorean theorem. You know, anytime we have two sides of the triangle given and we want to find the third side, Pythagorean theorem is the thing to do. So that would be leg squared plus leg squared equals hypotenuse squared. So x squared plus 48 squared is equal to 50 squared. Squaring the 48 and the 50, that gives us x squared plus 2,304 equals 2,500. So now it is time to subtract 2,304 from both sides. That gives me x squared equals 196. Then to get x by itself, I need to take the square root of both sides. And I know that the square root of 196 is 14. Okay, so I know that x is 14. Alright, and that was AC. So, okay, AC is 14. I'll just fill that in. Okay, we are also supposed to find the measure of angle A. Okay, so the measure of angle A, we're looking right here. From the perspective of angle A, the 48 is opposite, and the 50, of course, is the hypotenuse, well, no matter what. I'm not using the 14 because I just found that. Just in case I made a mistake on the 14, I don't want to use it. Alright, what if the real answer is 15? So don't use something that you just found if you can avoid it. Instead, use what they gave you, so that way you get one wrong but still get the other two right. Of course, this is a multiple choice question, so that wouldn't really apply. Anyway, you get the point, people. Don't quibble with me. So opposite and hypotenuse. Which function is that? Well, that is the sine function. You know what? I feel like in this whole test so far we have not used the cosine function. Alright? I feel like the cosine function is being neglected. So I really hope we get to see the cosine function before this test is over. We'll see. You know? Cross your fingers. Anyway, the sine of angle A, opposite over hypotenuse. So that is 48 over 50. Now, if you want to find the angle, you need the inverse trig function. So angle A will equal the inverse sine of 48 over 50. Inverse sine. Okay, so that means, well, I can just put this in the calculator. Okay, so if I want inverse sine, I hit second sine of 48 over 50. Alright, so that is 73.7 degrees. Okay, so I'm going to fill that in. So that's 73.7. Now, I also need to find angle B. So if I want to find angle B, and I already have angle A, the thing to do is to go subtract from 90. So 90 minus 73.7. That'll be angle B. Okay, so that is 16.3. Okay, so what's the form of these answers? So we're going AC and then A and B. Okay, so AC is 14. Okay, so that means we're down to either A or C so far. And then now it's A and B. Okay, well, you know what? They seem to have rounded to whole numbers. They seem to be rounding to whole numbers. So rounding to whole numbers, then this would round to 74. And this would round down to 16. 74 and 16. Okay. So this is angle A is 16 and angle B is 74. When in reality, it's the other way around. Angle A is 74 and angle B is 16. So that means that C is the correct answer. Alright, brilliant. Absolutely brilliant. Alright, so that was number 10. How about number 11? Okay, is it another one of those same type deals? What are the measures of angle A and B? Okay, I'm not going to be tricked this time. Whole numbers. I see it happening. Once again, if you want to find these missing angles, you will need inverse trig functions. So let's find angle A first. Alright, now angle A, from the perspective of angle A, 8 is adjacent. Of course, the 10 is always the hypotenuse, no matter which angle you look at. And then the 6 down here is opposite. Now, I was just complaining that the cosine function has not been used yet. Now, the reality is, since they gave us all three sides, we can use whichever trig function we want. So guess what I'm going to do? I'm going to use the cosine function, because I can use any one I want. So you can use a different function if you want to, but you should get the same answer that I'm about to get. I know the cosine of an angle is adjacent over hypotenuse. So I'm going to use these two numbers. Okay? So the cosine of angle A should equal adjacent over hypotenuse. So that's 8 over 10. If I want the angle, I will need the inverse trig function. So the inverse cosine of 8 over 10 should work. Okay, so the inverse cosine of 8 over 10. So I hit second cosine, 8 over 10. Okay, that is 36 point, oh yeah, they're rounding to whole numbers. So those will round to 37 if we're going to do whole numbers. Okay, so A is approximately 37 degrees. Okay, now if I want angle B, I only need to subtract from 90. So if I do 90 minus 37, that's going to give me 53. Okay, 53. So A is 37, B is 53. Okay, and here it is, option D. A is 37, B is 53 degrees. Okay, so that was number 11. Okay, now we just have some review questions. Solve for x given this little equation here. Let's try to factor it. Looking at the answers, they're all whole numbers. Well, not whole numbers, but integers. So that means this is probably factorable. So let's go for it, man. Let's just go for it. If this is going to be factorable, let me leave myself a little space. Alright, if this is going to be factorable, then it'll be a binomial times a binomial. So x squared can only be x times x. 2 can only be 2 times 1. Inner plus outer equals middle. So, inner we have 2x. Outer we have 1x. We're trying to get a negative 3, so I need a negative 2 and a negative 1 to make negative 3. Now that would make both of these negative. Now is that going to give me the positive 2 that I need? Yes, because a negative times a negative is positive. So there you go, we just factored it correctly. Now we're solving though. I mean, you can look at the answers and see they're all x equals something. So the way we go ahead and get that is by setting these factors equal to 0 and solving. So x minus 2 equals 0, x minus 1 equals 0. Okay, so here if I add 2 to both sides, and here I'll be adding 1 to both sides. So that's going to give me x equals positive 2, and here I'll get x equals positive 1. So, positive 2, positive 1. No, 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 yes. So the answer is D. Alright, positive 2 and positive 1. So that was the answer number 12. Let's see. Alright, number 13. Find the vertex of this parabola. Well, this is already in vertex form, so that makes it awfully easy. We learned that the vertex is the opposite of this one, comma, this one stays the same. So it should be positive 3, comma, positive 1. Simple as that. So there it is. The answer is A. Okay, is there a number 14? Alright, I'm going to zoom out. I feel like I'm missing something. I did number 9, number 10, number 11, number 12, and number 13. I guess that's it. This test was kind of short, a little bit short. So I hope this was a helpful review, and I will see you on the next video. If you're practicing for a test, please go back and make sure you can do every single one of these problems by yourself. You know what I mean? So rewatch the video or get a copy of the actual document and redo the problem. So if watching and following along with me is one thing, but I won't be there talking to you when you do the test. So make sure you can do it on your own.